Hello and namaste everyone. Welcome to my channel Sigmax. It's me, Vivek. This is my first video on YouTube and I am making videos on solving problems from physics and mathematics. I believe this will help you people on both understanding and solving the problems asked in NEB examinations. Today we are going to learn about dimension of physical quantities. Let's start with its definition. What is dimension? Well, it's a way to express any physical quantity to the power of fundamental quantities. What does that actually mean? Well, let's look at an example of velocity. Velocity is defined as distance traveled per unit time. We know that distance and time are actually fundamental quantities and their fundamental units are meter and second respectively. As per as the definition of dimension I told earlier, dimension of any physical quantity is equal to the dimension of fundamental quantities raised to the power. Now, if we know the dimension of fundamental quantities, then we can find the dimension of any physical quantity. But what are the dimensions of fundamental quantities? And how are we going to know about them? Well, you have to memorize them all. Is it hard? Obviously no. We only have 7 fundamental quantities, so I think memorizing them won't be so difficult. Now let's look at them. The dimension of mass is m. The dimension of length is L. The dimension of time is T. The dimension of current is I. The dimension of temperature is theta. The dimension of amount of substance is N. And the dimension of luminous intensity is J. But among these all, the most important in mechanics are M, L and T. That is the dimension of mass, length and time respectively. Since velocity is distance traveled over time taken, dimension of velocity is equals to dimension of distance divided by dimension of time. As distance represents length, its dimension is L and the dimension of time is T. Hence, the dimension of velocity can be written as V equals to L divided by T. Therefore, the dimension of velocity is L T minus 1, which can precisely be written as m0 L T minus 1 and read as the dimension of velocity is 0 in mass, 1 in length and minus 1 in time. In this way, we can find the dimension of any physical quantity, but we should first know about their valid formula. Let's practice with some more physical quantities. Let's take force. Force is simply defined as mass times acceleration. As earlier, the dimension of force must be equal to the dimension of mass times the dimension of acceleration. We know that dimension of mass is m and the dimension of acceleration is, well, we have to find it first before finding the dimension of force. As per its definition, acceleration is velocity over time. Hence, the dimension of acceleration is equal to the dimension of velocity divided by the dimension of time. Since we already know the dimension of velocity as Lt minus 1, the dimension of acceleration can be written as Lt minus 1 divided by T, which is equal to m0 Lt minus 2. Hence, the dimension of force can be written as m times m0 Lt minus 2. That is equal to m1 Lt minus 2 and can be read as the dimension of force is 1 in mass, 1 in length and minus 2 in time. You can also find the dimension if you know the SI unit of physical quantity in fundamental units. For example, force has SI unit Newton or kg meter per second square in fundamental units. Since kg represents mass, meter represents length and second represents time, the dimension of force can be written as mLt minus 2. Similarly, here are the dimensions of some important physical quantities. Please practice them, because practice makes man perfect. Finally, we have come to the end of this video. I hope you guys have fun learning about dimension of physical quantities. If you like this video, then please don't forget to subscribe, and the most important thing, please don't forget to share this video with your friends. I will see you guys in my next video. Till then, bye bye and enjoy physics.